Now that you've identified 3 features from your program backlog, or maybe it's your personal to-do list, it doesn't matter, let's look at how we can prioritize that work. And prioritizing features for optimal ROI requires a couple things. And one of the things I mentioned earlier in this course is that in a flow system, job sequencing is the key to economic outcomes. And what we mean by that is not so much the job itself, it's how we sequence the jobs through the system that produces the greatest value. In general, to prioritize on lean economics, we need to know 2 things. We need to know what is the cost of delay in delivering value, and that can be, cost of delay sounds like a penalty, and it is. It's just basically the net present value of the money we didn't get. Or via, the opposite polarity, but in the same direction, what's the value I didn't get? What's the value of that feature? So is there a penalty associated with cost of delay, or is there substantial value that I don't receive if I don't ship it? Doesn't matter. It's the same basic polarity. Really, what is the value of this thing? But we also need to know what is the cost to implement the valuable thing, because if, for example, there is a relatively high cost of delay, I'll just use the negative side of that. It's a really big penalty if we don't do it. Well, what if the cost is more than the penalty? Well, that seems kind of odd, but that could happen. Okay, it's a really valuable thing, but it's hugely expensive to implement. As we mentioned earlier, from Reinertson's view, if you only quantify one thing, quantify the cost of delay. So we need to do that. Fancy words seem kind of esoteric, if you will. Cost to implement valuable thing. Let's move forward. And I'm going to do this by thinking about manufacturing analogy because I think it's easier to think about. Let's say that I'm in the business of making crop combines, right? Big systems that work at harvest time. And I've got 3 of them on the line here. And my job is to make sure that I help my company make money. We're taking an economic view and delivering value at the same time. Those aren't different trends. And I have a combine here that's worth $2, let's just pretend. And I have another one that's worth $2, or maybe it's $200,000 or $1 million. And I have another one, but they're in different states of assembly. This guy could be done in a day. This guy's going to take 3, and this guy's going to take 10. Well, your first reaction might be, well, we're kind of behind on this one. Now, we have limited resources. We have a set of manufacturing capabilities. We have paint shops, and we have weldment capabilities. We have factory manufacturing capabilities. We also have a limited set of people, right? We don't have everybody we need to do the job, so I have to pick. If I work on this, this guy doesn't ship. So if you ask most people which should you work on, everybody will pick this one. Makes sense, right? So if the cost of delay, the value is equal, do the shortest job because you'll get the money quicker. Makes total economic sense. Well, let's take the other case. Let's work the other way and say, well, what if it's a little bit different? What if we have combines, okay, and I could finish each of them in 3 days? And here's a giant combine, and here's a medium-sized combine, and here's a small combine. I still have limited capacity. I'm always constrained, right? Resource constrained for sure. Which do I do? Well, most people look at that and say, well, wait a minute. If it's 3 days, I want to pick this guy, right? So if the duration is equal, pick the most valuable job. Well, it's never that simple. Okay, there's going to be combines of all shapes and sizes, and what's more, we're not making combines, we're using features instead. So what did Reinertson teach us? What he taught us is that we want to give preference to the jobs that can be done most quickly, right, and have the highest cost of delay. And the formulation for that is weighted shortest job first, right? We're picking the shortest job, but we're weighting it based upon its job size. So that means that our basic formulation is cost of delay, right, which is our value proxy, divided by duration, all right? Now, if we use that formulation and we just do silly things, we say we have 3 features here, look at the variation in duration and variation in cost of delay, and we pick badly, we have this huge cost of delay. We just didn't get the money for those features. They weren't delivered quickly enough, and we suffered all of this. Versus when I pick right, I have almost no cost of delay. And the reason is I took job A here with a short duration, which is extremely valuable, and I shipped it. So job B only had to wait this little bit of time versus job A, this hugely valuable job A, waited for all of C and B. So this job sequencing, that's kind of an interesting idea. And it gives us a heuristic, not a heuristic, an algorithm that we could use. Admittedly, an algorithm with some heuristics for the choices of the numerator and denominator built in that we can apply routinely, and that is called weighted shortest job first, which is equal to cost of delay divided by duration, straight out of lean economics and in particular Reinertson's work. I don't know if If there were variants of this before, I would suspect there were. I would think Don would tell us they were, but I certainly don't know. So let's move forward with that. So you're good to go, right? Cost of delay and duration. Okay, interesting. I have a new feature. What's its cost of delay and what's its duration? Well, it turns out those are actually really hard questions to answer. So we're going to have to think about that, and we're going to have to proxy these in a way that gets the same result without actually knowing the duration. For example, how do I know the duration if I don't know yet who's going to work on it? How do I know the duration if I don't know whether 3 teams are going to do it or 1 team is going to do it? How do I know the duration if the current team that I would like to do it is in the middle of a firefight on some other bottleneck? Very difficult to predict. Not to mention we haven't put any meat on the bones here behind cost of delay. So let's take those one at a time. Let's take cost of delay first. Now, what we've done here, I will say, I will admit, is somewhat arbitrary. I mean, it's not just pulled at random. It's what we believe are the right parameters to use when you consider the cost of delay. And the first one is, what is the value of this thing, right? The user or business value. Okay, now, how do I know? Well, we have a backlog. That's really important. Maybe not made as clearly by the slides as it could have. We have a backlog. We have a choice of many things. We're in a flow-based system. So when I go to pick my job, I'm going to pick one of many. I'm not just going to take this job and say, what is the net present value of that job? I'm going to say, does my customer prefer this one over that? What's the revenue impact of that? And is there a potential penalty or other negative impact? So this is an aggregation of, is it valuable to us and is it valuable to the business? And I don't have to have absolute values. I don't have to build a business case that says if we don't do this, we're going to lose more or we're going to lose this many dollars per day. All I have to know is that this guy looks pretty good, okay? But I'm not quite done because there are other parameters as well. What are the others? How does this change over time? I think that lean flow and job sequencing is the first time that I've seen in my career the inclusion of the importance of time to prioritization. And when you say that, you bring in a whole different dimension. If time is critical to prioritization, and it is, then how could I ever have prioritized only once? What does that mean? How does that value decay over time? Is there a fixed deadline? Do I have to ship this in time for the school? Here's my new tax system. We shipped it and made it available April 16th. Really a cool system. Nobody could use it at all. Well, maybe they have my solution and maybe they're locked in. Well, let's be honest. Sometimes our customers need us really badly. And in that case, this job, yes, they want this job, but they're with us. They're going to be with us and we'll get to them in short order. They want this job, but this guy here is still looking like he has a little more punch. So what's the time criticality of that? How often do we have to update? Well, if time is a factor, well, routinely, maybe every PI. And then the last one is an aggregation of 2. And like I said, these are arbitrary. They work great. We get tons of feedback as to how effective they are, but we recognize for a fact that we pick these because we think they're sensible. What else would this job do for me? Would this reduce the risk of a future job, right? And that's hard to answer in the absolute. Well, I don't have to answer it in the absolute. I answer it only with respect to the other jobs. This is my customer's favorite, and this is my current leading favorite. I look at this and say, oh, wow, but this customer favorite here, actually, that's going to enable a whole bunch of other things. So I'm changing my opinion now. I'm going to give it a higher rank in that regard. So it's getting a little bit bolder. Is the knowledge valuable? Whoa, maybe yes, maybe no. I don't know. It could be a really boring old feature. We've done it all the time. It's just another report. Easy to do, know how to do it, but it certainly doesn't, we don't learn anything new from it. Does it put us in a new business? Did it open a new market segment? Or does it allow me to sell to the customer that's next to that customer? All of these matter, and they're virtually impossible to answer in the absolute. If I take that feature by itself and say, what's the value of that? Well, that's valuable. Well, how valuable? I need to build a business case. Well, are you really sure that you're going to sell that many more widgets if it's green or if it has this software feature? Yeah, I'm sure. Well, how can you be sure? We don't have to do that. A time criticality. What's the time criticality of this? Low, medium, high? No. What's the time criticality of this one relative to this one? If they don't get this one by their next trade show, we're going to lose the order. Well, that's a pretty big deal. The fact that we use weighted shortest job first, but we use it on a relative basis, really gives us a breakthrough way to think about it. But this way of thinking only works when you're in flow. It only works when you have plenty to choose from. It doesn't work to create, absolute value of deciding whether to, enter an industry or whatever. It's not designed for that. It's designed for sequencing jobs, most of which need to be done. and it uses a relative value measures that we talked about. We'll certainly talk a little bit more about how to do that, how to compare them. So where does this take us? This takes us to the ability to calculate weighted shortest job first with relative estimating, and we're going to need to estimate cost of delay and duration. Now we have an interesting challenge. I don't know what the duration is because I might have 3 teams work on it, I might have 1. I don't know when I can get to it. I need a proxy. Well, job size is a great proxy. We know how to estimate our user stories. We know how to pull our user stories together and estimate them using our planning poker. We can do the same thing here because it's only a relative estimate. So again, we'll use job size relative to the other jobs. Doing relative estimating is a very quick technique that allows us to estimate the job size and relative value very quickly. Who are the stakeholders in WSJF? Who would make these decisions? Well, they're largely business owners and product managers and the other people on the teams who understand that, and customers. A customer could be involved as well. So now our formula converts to as follows. Weighted shortest job first equals cost of delay divided by job size, okay? And that means that the COD we've already defined as user business value, time criticality, and risk reduction opportunity value divided by job size, recognizing that's a proxy. Now, that seems complicated. It really isn't. So now we arrive at a formula, and that formula tells us that the job with the highest weighted shortest job first provides the greatest economic benefit. And we know what weighted shortest job first is. It's cost of delay divided by duration, but we have to proxy that with job size. We'll come back to that in a second, and we defined all these parameters, so let's proceed. So in your exercise, you identified 1, 2, 3 features. Let's just do a little thought experiment and pretend like I knew what you were talking about here. And in order to make this work, there has to be a 1 in each column. Why? Because we're doing a relative measure, and we need to make sure that these normalize against each other. So let's take user business value, look at job number 1 and say, it's important for sure, but boy, compared to this one and compared to this one, just not that valuable. Okay. Time criticality. Let's take another quick look at that. They're fairly patient on that one, so I wouldn't say, I need to start with my 1 here, so I have to find, that's not it, that's not it. It's going to be this one. That was the least time critical. Okay, how is this compared to that? That's about twice as time critical, and that's about the same, so I can have more than 1, that's okay. Risk reduction opportunity value. Now this guy's pretty big. This is going to put us in a new place, so I'm going to pick 8 again. What about this job? Not so much. And what about this guy? It's interesting. It's not a big deal to the user, but they have to have it right away, and that would really solve a problem. Okay, so we add those up now. So we have 7, and we have 6, and we have 18. Well, it seems like this job here is kind of winning the battle here, right? But we're not done yet. We look at the job size, and we go, how big are these jobs? Well, not unusual at all that this job with all this value probably is bigger. Well, that's not it. I got to find the smallest one. This guy's pretty small. Give him a job size of 1. Almost the same. No, we'll give it a job size of 2. This guy here, he's pretty big. Okay. So what do we know so far? Well, we know that we've taken some time to explore the independent dimensions of this prioritization sequence. We've worked with our key stakeholders to do that, but now we can do the math. And here's the math. Cost of delay divided by job size, 2 divided by 7. 3.5. 6 divided by 1, 6. 18 divided by 5, 3.6 or whatever that is. Can't do that in my head. Wow. This job here right in the middle. This is the most important job. Why? Let's look at it. Well, it has some business value. It's not particularly time critical. It has a risk reduction of pretty high, but it's a really tiny job. And small jobs go through the system faster, so it wins. These 2 guys, pretty equal. Let's do this job first, and let's come back and enter a new one and prioritize. There we have a model where routinely at every PI boundary, we update WSJF. There are tools in the kits that surround safe to allow you to do that. So every PI, we revisit this, the stakeholders agree, and we simply do our sequencing. What if we get it a little bit wrong? It's only 1 PI. It's no big a deal. We'll fix it in the next PI. Stakeholders are forced to think about the independent concerns. They separate value from job size. You have to estimate job size to get there, and you end up with a WSJF, and you pick the highest WSJF. So the one with the highest number is the highest priority. Okay, so now you're ready to run your exercise because you've identified your features before. So using the prior page, prioritize your features using WSJF, just like we did. Remember, estimate each feature one column at a time because we're doing comparative rating. We have to compare jobs on the same parameter. You can't compare the jobs to different parameters at the same time. You will have to estimate your job size at this time, of course, but only relative. Just pick the smallest job and call it a 1. Your acceptance criteria, we want to see those features prioritized with WSJF. So go ahead and do that, and it'd be fun to have a conversation if you're in class. We can't really do that here, to see if it met your intuition. And if it doesn't meet your intuition, ask yourself why not. And are you tempted to change the rules because it doesn't meet your intuition? Or are you tempted to understand why those rules produce the result that they did? The question is job size always a good proxy for duration? Well, maybe yes and maybe no. When might not that be the case? It might not be the case if I have 2 feature teams that are available to do the job. It might not be the case if, even though in theory it's a small job, I have nobody available to work on it. So we're going to have to make some adjustments for that. And when you do, you're going to adjust based upon the facts at hand. You're going to go, this job is bigger. It has a slightly lower WSJF, but I have 3 feature teams that could jump on it right away. And then you'll really be with the spirit and the fact of WSJF. You'll be prioritizing accordingly. So that's the completion of this lesson. And in this lesson, you learned how to organize cross-functional agile teams. We talked about eliminating the silos at the team level and to establish the key team roles, including the team itself and the product owner and the scrum master. We learned how to organize those agile teams into a synchronized art, synchronizing the sprint boundaries and aligning their boundaries such that they can do integration at least at those points. We defined some key art roles, include the release train engineer, the system architect, the product manager, the business owner, and a few others. We practiced how to create a program backlog, using your personal backlog as an example. And perhaps most importantly, we practiced prioritizing a real backlog with weighted shortest job first. So that's it for lesson 4. And now let's move on to lesson 5.